Hello everyone. In this video, we consider number 19 in section 5.3. Still, the integrand is a rational fraction. However, this is slightly different from number 17, where in the denominator we have two different factors. Now we do have x minus 1 in the squared. Okay. Now we may think to decompose this term as something like something over x minus 1 plus something over x minus 1. However, this may not, it does not make too much sense, because if we already have the same denominator, then the right hand side, the denominator is at most in the degree 1. All right. So actually, in order to fix this one, intuitively, we can consider to add the square term for the second. Okay. Now again, we will consider a constant a on top here and a constant b on top of the second term. All right. We would like to make this equation hold. And the common denominator technique, the first term numerator we have to multiply by x minus 1. Okay. Combine these two terms, we will obtain this. Now, only comparing the numerator, left-hand side x plus 1, right-hand side a times x minus 1 plus b. Well, this is true for all the x values. Can we take some special value of x to solve, for example, one coefficient first? Right? Checking the structure of the right-hand side, it seems that we could take x equal 1. Then left-hand side is 1 plus 1. Right-hand side will be b. Okay, immediately we obtain b equal to 2. All right. What about the other coefficient a? Sounds like we don't have trivial special value to choose from the right-hand side. Indeed, once we figure out the constant b, then we can rewrite the equation as x plus 1 equal to a times x minus 1 plus 2, since b is already figured out. Right? Now, a little bit algebra on the right-hand side, this will become ax minus a plus 2. Okay? And we only need to compare the coefficients, or we can just do a little bit algebra on these two terms. All right. Now x minus a, x plus 1 plus a minus 2 equal to 2. Roughly speaking, we wanted to move right-hand side to the left-hand side. Okay. Then we have an equation for this. That means this is hold true for all x. All right. Sorry about that one. I think I had the typo here. And it should be 1 minus a times x. Okay. Then because this is the left-hand side equal to 0, then it will force us to figure out the coefficient of the x equal to 0 and the constant term equal to 0. We have two equations here, only one unknown. All right. The first one tells us that a equal to 1. What about the second? The same thing. That means they are consistent. Okay. Now we only need to combine these. A equal to 1, b equal to 2. This is equal to 1, b equal to 2. Okay. Now with this information, we are ready to solve this. Okay. That will be 1 over x minus 1 dx plus b is going to be 2 and x minus 1 square dx. Okay. And the first term, the answer will be natural log, the absolute value of x minus 1. The second term, right, I think it's not too difficult to come up the answer. That should be 2 over x minus 1. You could apply the guess and check approach or using the U substitution potential. finally add a constant c. All right. So this is the answer to number 19 in section 5.3. Thanks for watching.